This is Joel, and this is like the second video on IPv6. In the previous video, we kind of went through some of the basic fundamentals of IPv6, right? We talked about the whole solicited non-multicast address, how the whole neighbor discovery works and how it compensates for not having ARP and so on, right? So you can check that out. In this video, we'll mainly talk about the address assignment, right? How the address assignment really works in IPv6, right? So let me go down to my whiteboard just to mention the various ways we can assign an IP address in IPv6. For starters, the very first way of doing so would be, let me grab that, yeah. The very first way would be static, right? Static way, very similar to how we do it in IPv4, right? We just go down to the interface and we put in an IP address. Very similar to that, you can do it in IPv6, that's static. Second one is called as SLAAC. Okay, what does it stand for? It's Stateless Address Auto Configuration, right? So it's Stateless Address Auto Configuration, and this is very interesting as well. So this is it's like poor man's DHCP, I would say, right? It's kind of it's an alternate way of doing. I wouldn't say a replacement, I would say an alternate way of assigning addresses when compared to DHCP, right? So the idea is pretty simple. I mean, you'll generally have, say you have a bunch of client, right? You're probably going to have some kind of a DHCP, you're going to have a router, right, in that segment, right? You're probably going to have some switches, right, or maybe directly connecting the clients, whatnot, right? But at the end of the day, you're going to have some kind of a L3 entity or a router, right? And there will be an IP address, or there will be a subnet, right, and there will be an IP address on the interfaces. So that idea of SLAAC is wherein, wherein say in this case a router will provide, right, when these clients come up, this guy will actually provide the prefix, right? Prefix or the network portion of it. I mean, I've talked about IPv6 address, right? So even in IPv6 address, just like your IPv4, we have like, the prefix or the network portion, and then we have the host or the interface ID or whatever they call it, right? You can call it as interface ID or host ID, whatnot, right? So in this very approach, what we do is the router basically provides this network portion which is being used in that segment to the clients, right? And the clients can then generate this interface ID themselves and spin up this IPv6 address and assign it to their interface, right? So and all of this communication happens in what we call as router advertisements, right? So router advertisements, these are the messages which we'll probably have a look at packet capture later, but all of this communication to and fro, right, whatever we talked about just now, all of that happens via router advertisements. Okay, so but the shortcoming of this is that I can, using this router advertisement, I can obviously provide the prefix, I can also provide the default gateway, right? But then what are other things which we need, right? When a client comes up, there are a few other things we need. And again, depending on client, we might need few other things. Like for example, if it's an IoT device, I might need probably the DNS server, right? Or even if it's a normal client or laptop, I might need to get the DNS server as well, right? I would need, in a normal DHCP, we can assign using options. We can assign a lot of things, right? We can assign if you're using wireless, you might be very familiar of option 43, right? Or you might want to give the DNS server details to the client and many other options, right? So all of that can't be done. Only thing which we can do here is we can give the network portion and we can give the default gateway information, right? That really doesn't, sorry, let me bring that up back again. Yeah, so as a result, you see this one doesn't really, it's good, but then it doesn't really serve all, like the complete purpose. If your use case is only to get the network section and the default gateway, go for it. Use SLAAC, right? So the third option, right, is basically using what we call, let me just write that again. Yeah, the third option is basically what we call as stateless DHCP, right? Stateless, we can say DHCPv6. It's not normal DHCP, right? It's stateless DHCPv6. And this is again nothing but a combination of SLAAC, right? Whatever we talked here, it is a combination of SLAAC plus some DHCP options, right? So this is not your full-blown DHCP. And why is it called stateless? See, I've mentioned it explicitly called as stateless. It's called stateless because the DHCP server will not maintain the list of DHCP addresses or IP addresses it is giving out. It doesn't really give out IP addresses at all, right? Basically, we follow the SLAAC method to give the network section and the default gateway, to the client, and then we use DHCP to kind of give those additional options which were not possible using SLAAC, right? To provide information like the DNS server or the TFTP server, right? All of that to the clients, right? So for that we use DHCPv6. So that's why it's a combination of SLAAC and DHCP. That's why we call it as stateless DHCP. All right. So the next one is the full-blown DHCP. So you might ask, okay, we have been talking about this, but is full-blown DHCP6 supported? Yes, it is, right? Just like your IPv4, we have a full-blown DHCPv6 here as well, right? So it basically supports, or it's basically very similar to everything in IPv4 except one nitty-gritty detail, which is it can't really give you the default gateway, right? Because in IPv6, just always remember this, in IPv6, the default gateway is always given out as part of router advertisements, right? So the default gateway, which we normally give out, in case of IPv4 DHCP, we used to give the default gateway as part of DHCP, right? But that's one thing which is not possible here. Okay, so we do it with router advertisements. We don't do it with DHCP. Okay, the rest, everything full-blown DHCP will support. It can give you IP addresses, it can give you options, it can give you DNS server, TFTP server, whatnot, right? It can provide all of that information to you except the default gateway. And there is one interesting option. I mean, this is I would say the fifth way of giving IP addresses, and that's nothing but, it's again DHCP based. So that's why we call it as DHCPv6, but it's called as prefix delegation, right? So this is again pretty interesting. I would say it's something which you would use, or the service providers, when they are assigning this, IPv6 networks to you, right? They basically use this, and then, or you can probably use it in a core network as well. But I will not spend more time explaining this right now. I'll try to explain this while we do the configuration, because it really helps. The configuration and looking at the whole scenario really helps to explain this, else it becomes a little tricky, right? So just to recap here, nothing very completely, or there is a lot of overlap with IPv4. You have your traditional static, you have your traditional DHCP, but in addition to that, I would say this SLAAC is something new with DHCPv6, right? We did not have this in IPv4. So the SLAAC is pretty interesting, wherein you can give out your network section as well as the default gateway, and all of this works with router advertisements, right? These messages, and that kind of spills over even into the third way, wherein we use that SLAAC and then we use DHCPv6 as well. It's a combination of that. And then this is your traditional DHCPv6, and we have the prefix delegation, right? So that's a quick couple of minutes overview. Now let's jump on to the configuration and let's look at how to do this. All right. So the very first configuration which we will actually be trying is the static, right? So the devices which we'll be playing around for this is mainly let's go back to topology, which is R3 and R4. Okay. Sorry, R3 and R6, right? This particular link, right? The link which basically connects Ethernet 0/2. That's the link which we'll play around. All right. So let's go to the device. We can close this probably, and let me go to the device. There we go. That's R3. And what do we have here? So let's see. Just give me a second. Yeah. So let's see what do we have as of now. With respect to IPv6, or do we have CDP? Let me see if I have CDP. Yeah, we have CDP neighbors, and you can see the link which is connected to R6 is the Ethernet 0/2, right? That's the link. Okay. So let's see the IPv6 addresses as of now. So show IPv6 interface brief, and there you go. We can see all the information. Now my topology has a little bit of configuration, right? So there are a lot of other cool things which we'll be doing using the same topology. But for now, the interface which we are interested in is the Ethernet 0/2, and it is completely unassigned. Okay, so how do you enable IPv6, right? And when we are doing it statically, let's do it first. Let's go to conft, let's go to the interface Ethernet 0/2, and just by doing IPv6 enable, right, our job is done, right? Because the link local address is automatically generated. You don't even have to assign it, right? So now we can go and do show IPv6 interface brief again, and there you go, right? We have this generated. Cool, pretty simple, right? Now there's a little bit of information which I would like to give here. How did this even come into effect, right? So I think during my explanation, I think in the previous video I talked about the link local addresses, and it is FE80, right, /10. That is the that's the link local address. So how did all of this rest of the stuff get generated, right? So by default, it picks it from the MAC address, the burned in the MAC address which is burned into the network card. What I mean is, so if I do show interface Ethernet 0/2, right, and if I probably pipe it and include the BIA, let's see. So this is the MAC address, right? You have AABB, CC00 and 3020, right? So you can see here that's the one, but it's obviously not exactly like that, right? And you might be confused, okay, how did this come out of this, right? The reason is because, IPv6 address is like 128-bit, right? And your MAC address is just 48-bit. So you have to do a little bit of, let's say, magic to get, to kind of fit this inside this, right? So what they do is they kind of, they kind of like flip the 7th bit, right? So that this is 4-bit, and this one has another 4 bits, right? And they basically take the 7th bit out of that and they flip it. So that's how you get this A8BB, right? And then what they do is, you can see here there is CC00, right? So in between this CC00, they go and insert FFFE, right? You can see here, you have the CC00 and they have inserted this. So that's how you can, this is basically called as EUI64 way of converting, right? So they take the MAC address and from that they convert it, they add that FFFE in the center and they invert the 7th bit, and that's how you get the, the complete EUI64 generated, link local address. Okay, so we have got the link local address. What else? Can we ping this? Can we, maybe what we can do is, let's go to the other side, which is R6, and let's try to do the same thing over there as well, right? So we'll do, as of now there is nothing, I can show you that. Show IPv6 interface brief. See Ethernet 0/2, there is nothing. So what I'm going to do is I'm going to get into interface Ethernet 0/2, and I'm going to say IPv6 enable, right? And if I do again, okay, and there you go, we have the IP address or the link local address generated. Okay, now what I can do is I'll quickly grab this and I can, let me see if I can ping from here so we can check out what's happening. So let's see if we can ping. So let's do ping and let's put in this address and let's do, okay. So once you do this, what it is going to do is it's going to ask you for the output interface, right? Because it really doesn't have a route for this right now. So it's going to ask you, how do I get to it? How do I get to that? I'll have to mention the interface. In my case, it is Ethernet 0/2. So I'm going to mention that. And there you go, the ping goes through. There's another easy trick to get around this. You can see here, instead of waiting for the output interface prompt, what you can do is you can put in a percentage, right? Right, so what I can do is rather, grab this whole thing, right, put in the address, put in a percentage and put in the interface directly, right? So if I do the same thing, ping, put in that whole thing and there you go, that works, right? So this is one of those small cheeky, way of doing it, wherein you don't have to mention the output interface separately, rather you can mention it as part of the address, but just put in a small percentage and then you're good to go. All right. So, we don't really need this IP address anymore, so I'm going to just say no IPv6 enable on the IPv. I just want to put it here so that I can show you the ping part, right? So I'm going to remove it from the R6. Let's go back to R3. Even on the R3, let's actually remove it. Let's remove it from the interface where I put in early, which is Ethernet 0/2, no IPv6 enable, right? So this was, I just wanted to show you that your link local address, you don't have to manually give it. You can make the interface card NIC automatically generated for you by just enabling IPv6 on the box, on the interface, sorry. Okay, so now we have removed it, so it should have basically gone away. Let's look at that. If you do show IPv6 interface brief, there you go, from the Ethernet 0/2 it has gone off. Now this time we are gonna try giving it a global address. We gave it a, we saw how the link local works. Let's try a global address. Global is basically the public address, the internet routable or whatnot, right? So let's say IPv6 address, and let's say something like 2001 db8 and 100, right? 36, you can, yeah, 36 probably, or 40, whatever you want. But what I'll do something interesting here is I will just give the network part of it. So this is the network part of it, and I'm going to put in 2 colons, which means it just symbolizes zeros at the end, and I'm going to put /64, right? That's the subnet mask basically, just like your IPv4, you gotta give a subnet mask. But at the end, I'm going to say UI64. See, there's an option called UI64 at the end, right? And I'm going to hit enter. So what this is going to do is, let's have a look at this. So it's going to do show IPv6 interface brief, right? See what it did. So this is basically what I gave, 2001 db8 136. But then at the end, what it did was it used that trick which I talked about a minute ago, the UI64, right, where it takes it from the MAC address and then inserts FFFE and inverts the 7th bit. It basically did that and used that as the interface ID, right? So it generated, I mean, it took a part of information from what I gave, the network part, and then the interface part it generated on its own, and it is using that as the IPv6 global address, right? Very important. And then you also see it has automatically generated the link local address as well. I did not specify it, I removed it actually, you can see here, I had removed it, but then it has generated on its own, and it has, and you can see it here. Very important point, right? Something to be noted down here is, there's a misconception that people think that, this part, whatever is this, right, this, the interface part, interface ID part is always generated from the MAC address, right? And that's not true. The link local address, uses the MAC address, the burned in MAC address to generate the host part, right, using that UI64. But then the global address, right, especially whenever we are automatically assigning it in this way like we did, the global address always picks this interface ID part from where? From the link local address, right? So it picks it from here. So I mean, in actual terms, what it is called is, this section of the link local address is called as client identifier, right? And that's basically kind of pulled down in here, right? So this one is actually fetched from here and not always from the MAC address. Now, because we have kept everything default, it appears that this one, everything is pulled from the MAC address, but that's not true, and I can prove it to you. So what I'll do is, now I will change the link local address, and we will see if our I will manually change the link local address. Okay, how do you do that? You can just say IPv6 address, and I'll say something like FE80 : probably 3, right? And I'm going to say this is my link local address. Okay, so there you go. I changed my link local address on this particular interface. So now let's see what has happened, right? There you go. So on the Ethernet 0/2, what was it? Yeah, 3. Okay. So we have changed it. You can see it has changed from here to this. And what has happened immediately? You can see this one has changed, right? And it has picked this client identifier, or the interface ID. It has picked it from here. Though the MAC address is still the same, MAC address has not changed, but still you can see it changed. So basically that's what I wanted to kind of put it out there. Just let me just even write it down so that we remember it. So it's always this way, right? This is my, give me a second. Yeah, so let me use the pen. So the link local which we have, right? So this guy gets it from where? He gets it from the MAC, right? It gets the interface ID or the host ID from the MAC using the UI64. And then the global address, right? This one always, fetches it from the link local. Okay, so the client identifier for the global is actually fetched from here, right? But generally by default, what we do is we don't change the link local, right? As a result, it appears as if the global is also getting it from the MAC, but that's not true. Global always gets it from link local, and link local is kind of like influenced by the MAC address. Let's go back. All right, so what did we do? Let's come here. Okay, so that's what we checked out. Next, so what we'll do next is let's probably change, right, the address. Yeah, let's clear this up. What I mean is, let's just remove that link local which we just now added, right? Which was the link local, yeah, this one. So let's change this. How do you remove it? Just put in a no over there, and there you go, it's gone. I can quickly check if that took effect. Yes, it did. You can see here, it has gone back to using the MAC address. And then this is influenced from here, right? That's what we have. Now what I'll do is I'm not interested, I mean, let's say this address is not very readable for me, so I want to do a manual assignment, right? A static assignment. So how can I do that? I can do IPv6 address, right? I'm okay with so much, so I'm gonna grab that, and at the end I'm gonna say 3, right? I'm gonna put in the mask /64, okay? So I've done a static assignment of the global address, and what's going to happen? Something interesting, right? You can see this is the address which I just now added, but the old address is still there. So this is behaving differently than IPv4, right? In IPv4, the address used to overwrite, but here it doesn't. The reason is because in IPv6, a particular interface can have multiple addresses, right? So what you have to do is, you obviously need to remove that UI64 which I had put in earlier, right? So this was the one, right? So if I do a no, there you go. So that goes off now. Now what I can do is, if you see here, this is what I have, right? So you can see the new address which I've assigned is visible here, and the link local is still here. Can you observe there is one more interesting thing which just now happened? I changed the global address, but when I changed the global address, the link local did not change. The link local, whatever was there before, you can see here, whatever was there before, it has remained as is. Right, so that's an important point as well. If you change the link local, then it will influence the global, right? That is what we saw here, right? We changed the link local from here to, where is that? We changed it to this one, not this, yeah. Sorry, let's go up. Yeah, this one. So we changed it to this one, and you saw the global changing, right? So that's the flow. You change the link local, it will influence the global, but if you change the global, it doesn't go back and change the link local. It doesn't influence that, right? So the recommendation is that when, if you are changing the global manually, then better change the link local as well manually. So maybe you can do something like earlier, whatever I did, right? This one, right? So now we have changed both statically, and we should be good, right? There you go. So now we have both of these just like we desired, right? Cool. And the other important point is, you might ask, why do these both interfaces have the same address? Again, it goes back to what I was explaining earlier. Link local, the scope is just the segment. So I mean, having the same address in different segments doesn't really matter, because it's limited. The scope is limited to only the segment anyway, right? So you can have the same address used in different segments. Okay, so that was a quick explanation of what the very first part, which is the static way of assigning, right? So we assigned statically the link local, we assigned statically the global. We found this whole relationship here, right? The UI64 concept, which is the MAC address kind of influences the link local. If you do it via the UI64 or the automated assignment, and then the global address basically can or will be generated based off the client identifier which is there in the link local. So that's the flow. And we also saw that when you change the link local, the global will get influenced, whereas when you change the global, the reverse won't happen. Okay, cool. Let's go to the second option, which is the SLAAC, stateless, right? Stateless auto configuration. How does that work? Like in stateless, I talked about or let's actually go and configure. It's been too much theory today. So let's go to the configuration. Let's go back to, for stateless, are we still going to be using R3 and R6? I think we are, right? So let's go to R3 to begin with. And on R3, what do we see? Let's do show run. Maybe do show run. And let me show you what do I have apart from this. So I'm going to say do show run and probably include IPv6. My bad. Okay, so that's what I have. I just want to show you that I have enabled IPv6 unicast routing and IPv6 Ceph, right? These two things are really important for that router advertisements, which are kind of like the crust of your SLAAC. We talked about router advertisements before, right? So what we'll do is with this one, so we'll start by enabling what we call as the neighbor discovery, right? So we'll enable the debugs for that. So we'll say debug IPv6 and ND, I guess. Yeah, there you go, right? So we are enabling neighbor discovery, and you can see when I enabled ND, ICMP got enabled because neighbor discovery is riding on top of ICMPv6. Okay, cool. So that's important. All right, so we have started the debugs, and you can see already the router advertisements are going off, right? And we can see that here. So a little bit of information you can see there are 2 of those which have gone out, right? We can see the MTU, we can see the prefix, correct? So we have the prefix, and this is because this is on Ethernet, I think 0/1, and there's one more prefix which is on Ethernet 0/2, right? And you can see that information is going out. And then you have a couple of things called as, so these numbers which you see here, they are actually the valid and the preferred time, right? So they are basically the timers involved with the IPv6 prefix, right? You can read more about that. It's basically a very simple idea about, you know, the liveliness of the IP address, right? So you have 2 timers. One is like the valid time and the preferred time. The valid time will always be greater than or equal to the preferred time. Okay, cool. So that's that. You can see the router advertisements basically going out, right? You can see these are the router advertisements. We'll probably have a look at the packet captures later. But what we'll do now is let's also look at this interface in a little more detail. So what we will do is show IPv6. Show IPv6 interface Ethernet 0/2. Okay, there you see, we see some information about the router advertisements, right? Here you can see the ND router advertisements are sent every 200 seconds, right? And the advertisements, they live for 1800 seconds, right? So all of this information. So all of these parameters you can change using configurations. Like for example, let's get into it. So we'll do conf t, and we'll say, we'll go to the interface Ethernet 0/2, and we'll say IPv6 ND and router advertisement RA, right? And put a question mark, and you can see these are variables which you can change. You can change the interval, you can change the lifetime, MTU, and so on, right? So if I want to probably reduce the interval from 200 seconds to say 30 seconds, I can do that. I can change this to interval 30 seconds. Sorry, just put in 30, and then if I do the same command again, right, basically, where is that? This one. Let's do that. Now it's more frequent, right? You can see here it has changed. So basically you can change all those parameters however you like, right? We can also change the valid time and the preferred time, right? So we can change it to something like this. We can do IPv6 ND prefix, maybe default for all the prefixes. We can change, say this is the valid time, I can change to 600 seconds, and if I want the preferred time to be reduced, I can make it 300. There you go. So that would, you know, go in. Right now you see it has changed, and you can see all the values are going with 600 and 300. So you can basically change the parameters or attributes of the router advertisements, which are very much critical for your SLAAC to work, right? Because in SLAAC what we are really trying to do is this particular router is going to send the network portion of the, you know, IP address to the client, and it will also send the default gateway, right? And this is one of those zero touch way of assigning IP addresses, right? So I mean, in the first option we saw we were doing it manually, but here we are going to use some kind of a automated way to do it, and that's SLAAC. So that's configuration on the R3 side. I mean, yeah, so that's mainly it, right? So now because R3 is acting as a server. Let's go back to our topology, R3. So this one is acting as a server for our SLAAC, right? And it will continuously send those router advertisements. And on the client side, which is my R6, let's see what we have to do. So let's go to the R6. Let's get into the interface. Let's see if something is there first. Okay, that's good. So we'll get into interface, conft interface Ethernet 0/2. What do we do here? So we have to simply say IPv6 address autoconfig. That's it, right? I should have probably enabled, do I want, probably not needed. Let's go back here only and check, right? There you go. We can see the cool, what do you say? We are basically going to be seeing all the logs here, right? So as soon as I configured that, you should, there should have been some kind of a solicited message RA which should have been sent out. So it's kind of difficult to dig through all these logs, but let me try to see if I can find it somewhere here. Give me a second. So it's, yeah, kind of difficult to search through this, but anyway. So basically you can see the logs here. Maybe if you are doing this locally, you can, if you have some patience, you can check through that. But now let's go to R6 and let's see if we got the address. So we'll do show IPv6 interface brief, right? And there you see Ethernet 0/2. We have obtained what we wanted, right? So you can see the network portion of it, 2001 db800.36. So this is obtained from from the R3, because this is the network portion of it from there. And then this router is basically generating this based on its own MAC address, right? Because if you see the MAC address, show interface Ethernet 0/2 include the DIA, you will basically find, yeah, you can see this is the MAC address 6020 ending with 6020, and that's what you see here, right? Now you can control the host portion with with the link local address, right? You can, we have looked at that before, right? But we can again have a look at it here. So if you're not happy with using the MAC address as the host portion, you can control it. How? By changing the link local, because we learned that whenever you change the link local, it will influence the global address. So what I can do is here, simply get into the interface Ethernet 0/2, and I can say IPv6 address, and say if I want something clean, if I say FE0::, because it is R6, I'm going to go with 6, and I'll say link local, right? So once I did that, what I'll see is, there you go, right? So you can see my link local changed, and in line with that, the global also changed. The global is still using the network section from what it obtained as part of SLAAC, as part of auto configuration, but the rest of the part, which is the host part or the interface ID part, it is picking it from from the link local which we changed. So you can control that way, right? If you define your link local whatever you want, you can control the host portion of the global. Okay. The next thing is default gateway, right? Let's look at the routing table of this guy. Do show IPv6 interface brief. I told you, I do show IPv6 route, my bad. So I told you that in SLAAC or in auto configuration, basically we also get the default gateway. In this case, R3 should be my default gateway. But you see, I haven't received it yet. There is something called NDP here, but if you look at the legend here, it basically says this prefix, right? But I haven't received this ND. I'm just looking for this ND, and I haven't received it yet, right? So how do I get it? As of now, I have not received. So for that, there is probably one more small piece of the configuration which has to go in R6. So remember, I put in this command earlier. It was IPv6 address autoconf, but actually we need to put one more keyword which is default at the end of it. So once I do that, and now if I check the routes, right? Okay, still not. Did it get it? No, I can't see the default route yet. We have to wait for a few seconds. There you go. Now it is obtained, right? See, earlier it was not there, but here it has obtained, and that's the default route. So you can see the default route is nothing but R3. So that's the whole complete picture of your SLAAC. That's how people use it. People use it to kind of get the default route as well as the network portion of the IPv6 address for that segment. Okay, so that's the complete routing table of IPv6, but this is the route we just got inserted because I changed auto configuration command, right? That's why. All right, so and just to prove you that I'm not getting this out of DHCPv6, so I can check that. How do I do that? Do show IPv6, IPv6 I think DHCP, right? DHCP interface Ethernet 0/2. There you go, right? No output at all, which means all of this information which I'm getting, the network part and the default gateway, I'm not getting it via the DHCP. I'm getting it using the SLAAC. Cool. Next, we are done with 2. We are done with what? We are done with 2. We are done with 1 and 2. Let's do stateless DHCPv6 next. So let's do that. Alright, so we are doing the full-blown DHCP now. So let's get back to our devices, which is R3 and R6, right? So we are doing what? We're doing this fourth option now. Sorry, my bad. We're actually not doing the full-blown. We are doing stateless DHCP, my bad, okay? So we're doing stateless DHCP. So again, we're going to use R3 and R6. So let's come back to R6, and this is where we ended the previous one. What I'll do is, let's actually see if we have some debugging on, right? Because we want the DHCP debugging. So let's see, do we have debugging? Do debug IPv6 DHCP. Yeah. So we are gonna do the debugging of IPv6 over here, right? And let's actually disable all the other debugging over here because we don't want this anymore, right? So we'll say, how do we do that? Pretty simple, right? So we'll say undebug all, so undebug all, and we will basically do debug IPv6 DHCP. Okay, so we have enabled DHCP debugging on both of them. Okay, there's one capture which I kind of forgot showing you guys from the previous one where we did the SLAAC. So I had pulled on the capture here. You can see the capture here, and this is the router advertisement which I was talking about, right? So you can see the router advertisement here going off, and there should be some kind of a solicitation message which should have come later, later in the section. So maybe somewhere here, yeah. You see there is a neighbor solicitation, right, coming from R6, right, towards my towards the solicited multicast node, and once I got the solicitation, there is like a neighbor advertisement which has gone in, and that's basically neighbor advertisement, right? And the router advertisement is over here. This is how the router advertisement looks. So this is the router advertisement going from R3 to this multicast address, and we can see in the as part of the router advertisement, we will in the ICMPv6 section, we will basically be see here. This is the prefix information, right, which I was talking about. So this is the prefix information which is basically sent as part of the router advertisement. All right. So step number 1 would be, let's come to R3 and we'll configure the DHCP scope, right? Because we really want DHCP scope here because it is what we are trying to do is stateless DHCP, right? So we'll start with DHCP, but observe this carefully, right? We'll do IPv6 DHCP and we'll define a pool, right? And we'll call this, I don't know, maybe 6 pool. And inside that pool, observe that we are not going to define the DHCP addresses or the range. Normally in a DHCP server, we define a range and we are going to allocate IP addresses in that range, right? That part we are not going to do here. Why? Because it's stateless DHCP. We are making SLAAC provide the IP addressing part. We are using DHCP only for the options part of it, right? So what we'll do is we'll just provide the whole DNS server. We'll just mention DNS server. I don't have a DNS server currently, so I'll just put in a random IP. I think probably the IP of my R1 or maybe something like that. So I'll say db8 100:100:1. Right, so that's my DNS server, and I'll also put in a domain name. I'll say bitsplace.com. There you go, right? So domain name is done. That's it, right? So you see it allows me to create a DHCP pool without defining the IP address range, which is pretty cool. So now I can go to interface Ethernet 0/2 and I can say IPv6 DHCP server and 6 pool. There you go. You can see the DHCP server is starting. As soon as you put this under the interface, you can see the DHCP server start. Nothing really happens though, right? Which means, you know, my R6 over here will actually not be, I mean, basically you can see the DHCP server started, but we are not seeing any DHCP related messages going forward, right? So we have to fix that. How do we do that? So what we do is we will have to put in one more command, which is IPv6 ND, right? And we have to say other config flag. There you go. So now, there you go. Now the DHCP started flowing off, right? And you can see it will probably take a few more seconds. Let's wait. Yeah, actually we can see the logs already on the R6 side, right? On the R6 we can see, so you can see there is an information request which has gone, right? And there is a reply which has come, right? And we can do quickly, what we can do is we can do show, or whatever the command which I was trying earlier, do show IPv6 DHCP, and there you go. Now we have some information. Earlier you see, when we ran that command over here, earlier, see, there was no output for that. Now because we are getting some information via DHCP, you can see that output comes up. And what is that? You can see the DNS server has come up and the domain name has come up. The IP address we are still, you know, depending on SLAAC, right? We are not doing it using DHCP. We are using DHCP only for the options part of it. And that's why, you know, this is what we have. So on R6 we can see, you know, you can see the logs here, right? It has sent a request and we have received a reply and so on, right? So that worked. So whatever we were trying worked, right? So we really, what we have achieved now, if you do show IPv6 interface brief, the address Ethernet 0/2, right? This is coming from SLAAC, right? At the same time, via DHCP6, we are getting the whole DNS server and domain name, right? So this is a very interesting combination which is generally used in the production network as well, because SLAAC by itself doesn't provide these options. So you have to use it along with DHCP to kind of give you the complete solution. Okay. The next one is basically we'll go for a full-blown DHCP. So that was our fourth option, right? Full-blown DHCP. So how do we do that? All right. So since we're doing full-blown DHCP, I kind of cleaned up my interface configuration. So on my R3, you can see I just have the IPv4 address. I have the link local. I have the what is this global address, right? And I just have this. I mean, I can remove this or keep it. Doesn't really matter. But yeah, I've removed all the other stuff. I've removed the DHCP configuration which we did earlier. And under R6, what do we have? You can see I just have the IP address and the link local. Removed everything else. I've removed the SLAAC configuration. So it's brand new now. So we are good to go and configure the full-blown DHCP, right? So we already have the DHCP server from previous one. So let's look at that. Show run probably section 6 pool, right? So this is the DHCP server we have. So we'll just add to this. So we'll get into this DHCP server. We have DNS name and domain name already. But what we'll do is we have to configure the prefix, right? Because now we are using the full-blown DHCP, which means we want the DHCP servers to hand out IP addresses as well and not via SLAAC. So we'll do 2001 db8, right, 100:36 because this is for the segment connecting R3 and R6, and zeros at the end /64, right? So when you put double colon, it basically means that, you know, it's all zeros at the end, right? So /64, is that it? I mean, we can end it here, but if you want, if you're feeling a little bit, I mean, if you want to feel like doing something else, you can do that as well. You can add those some other parameters like lifetime, right? I talked about that valid time and the preferred time earlier, so you can change those. I can put for this particular prefix, I can change basically like your think of it as a DHCP lease time kind of a situation, right? So for this prefix, I can put a valid time as 600 and maybe the lease preferred time as 300, right? There you go. So I've put in the address now, right? In addition to that, I can also put in some information like where do I want to store this DHCP database, because it is now stateful DHCP, it's not stateless anymore. So I can do IPv6 DHCP database, and where do I want to store it? Maybe in the NVRAM, right? So and I can give some name, something called DHCPv6.dat file, and maybe there are some parameters like if I want to write delay, right? Write delay will basically write it every, say in this case, 60 seconds. So we are basically writing the DHCP information to a database every 60 seconds. Okay, so that is that part, and the next is what? So we have configured we have basically added to our existing DHCP server configuration. Let's go to the interface and enable this. So we'll go to interface and we'll say IPv6 DHCP server, right? What is the name of the server? It's called 6pool, and we'll say so you can actually this is enough, but then there is another interesting command here called as rapid commit, which I normally use, right? And I'll tell you the actual use of rapid commit in a minute, but for now let's just enable it and I'll show you the use of that, right? So there you go, that's what I've done. And on IP, on my R6, right, which is my client, so I've configured my DHCP server, but what about my client? So on my client, what I'll do is I'll basically go and say IPv6 address DHCP, okay? And remember, I already have my debugs on, so as soon as I put this in, right, I should start seeing the 4-way handshake happening. There you go, awesome. See, so we have the solicit, advertise, request, and reply. So you saw the 4-way handshake which has gone in, and you can see it is also getting the bitsplease.com as well as it should also get the DNS server as well, right? So that's how you do it. So that's basically your 4-way handshake, right? So we saw the 4-way here. Now I told you that I enabled the rapid commit, right? So I did the rapid commit. What's the use of that? By doing that, you can actually reduce this 4-way handshake to just 2-way handshake, right? So we can reduce this whole process to just 2-way. How will we do that? So what I can do is I can probably shut the interface for a minute. So when I shut it, that IP address gets released. And then I can, once I shut it, I can basically go to the same command which I did earlier, but instead on the R6 as well, I'm going to do rapid commit, right? And then I'll do no shut. And when I do no shut, you will start seeing, see the interface is coming up, and there you go. The DHCP has gone through, but this time we just have solicit and reply, right? It's no longer the 4-way handshake. It is reduced to just 2-way handshake. Got it? Cool. We can also go to R3 and see that DHCP information. We can do show IPv6 DHCP bind, right? We can see that this was the address which was handed out, right? And we can see that information here. Yeah, so that's there. What we can also do is probably, what is this IP address of this R3? Let me do show IPv6 interface brief. So this one, right? Where is R3? Yeah, this one. So this is the address of the DHCP server itself, right? So what has happened now? We have enabled DHCP server on R3. R6 is my client, and R6 has obtained an IP address as well, right? We can check that. Do show IPv6 interface brief, right? There you go. So this is the IP address which it has obtained. Do you think I'll be able to ping the DHCP server? Let's try. So I'll do ping. Let's put in the IP here. See, it's weird, right? I mean, I'm really getting the IP addresses from the DHCP server, but I'm not even able to ping the DHCP server. That's interesting. Let's check if the link local is pingable. What is a link local? This one. So let's grab that. Let's go to R6 and do the same thing, but let's try this. And the output interface is Ethernet 0/2. So let's grab that. That's pingable. Interesting. So I'm able to ping the link local, but not the global address of the DHCP server, or R3 in this case, right? We can try to debug this. Why is it this happening? So if I do show IPv6, let's look at the Ceph table. So in the Ceph table, let's try to find this guy of R6, right? Let's see if, yeah, there is no route in the Ceph. Ceph is nothing but the forwarding information base, right? And we are not able to find over there as well. Okay, so why is this really happening is because, actually let's look at the routing table. Yeah, there you go, routing table, right? And you can see here what has happened is R3 being my DHCP server, it has handed out the IP address, but it did not provide any mask or subnet, basically the subnet mask, right? And my R6 automatically put it as /128, right? So you can see R6, there is no route for, there is no route at all. There is no route for the address which I'm trying to ping, which is my R3, right? Though they are in the same subnet, though they are in the same network, which is 2001 DB80036, right? There is no route for this network in the routing table, because on one side R6 is assuming the subnet to be /128, whereas on the other side, which is R3, it is assuming it to be /64. So because of that, there is no route to get to R3, right? And I think if you look at the messages here, we'll probably get to know that. See here, it is adding the interface and it is adding it as /128. So that's the issue. Now there are different ways to fix this, right? So first way would be, what I can do is yeah, so give me 1 second. Yeah, so one way to fix it, we were talking about this, right? One way to fix it would be to tell R6 to get this prefix from where? From autoconf or from SLAAC, right? So what I have to do is, on R6 I just need to say IPv6 ND autoconf, and I'll say prefix. So I'm basically telling, get this prefix, get the correct prefix, which is /64 from SLAAC. So once I do that, do show IPv6 route, right? There you go. We have obtained the correct /64 now, right? Which means now I'll be able to ping this guy, the one which I was not able to ping earlier, right? So if I do ping now, there you go, right? I'm able to ping, correct? So we just need to get the prefix from SLAAC, or from, yeah, basically from SLAAC, right, using autoconf. Okay, so what's the final configuration which we have here? Do show run interface Ethernet 0/2. So this was the final configuration which was needed on the client for running DHCP, right? We did the rapid commit, and then we added this one line because we wanted to get the correct, network prefix. Okay, so that was on one side. Okay, what else do we want to check here? If you want, we can also quickly look at the database which we created here for DHCP, right? How do we check that? We can do something like do more, and what was the name of that? I forgot. DHCPv6 .dat, I believe. Oh, it's not able to find it. Okay, so we'll probably have to put the NVRAM part. There you go, right? So this is the database, and you can see this is the address which has been handed over, and that is being logged here as well. Okay. The other important thing which I also want to show here is, we really did not have to do this if we had some routing turned on, right? What I mean is, let me actually remove this. So let me remove this. So when I remove this, my ping will no longer work, right? There you go, my ping is not working. But instead of using, this is option number 2, right? Instead of using SLAAC, you can put in a default route as well. So what I can do is, instead I can come out of this and I can say IPv6 route, and I'll put a default route manually into my routing table, and I'm going to point it to what? Ethernet, I think 0/2, the interface, and FE80, which is my R3 ::3, right? So I'm going to put a default route of this sort, and let's try to ping now. There you go, the ping works, right? So you have multiple options to solve that problem, right? Either you can get the prefix from SLAAC using autoconf command, or you can, if you have routing, generally you'll have routing, right? You'll have some OSPF or some kind of IPv6 routing, and that will take care of, you know, providing a route to that R3, and as a result you'll be able to ping it. Alright, so that's mainly about DHCPv6. Okay, so now we'll get to the last one, which is the DHCPv6 prefix delegation. This is pretty interesting, so let's get to this. Alright, so for this final configuration, what I've done is, again, I've cleaned out all the configurations from R3 and R6, whatever is not needed. Like you can see here, we just have the you know, link local and the global address, and obviously this doesn't really impact. Going to R6 as well, I've just kept only these two things, right? Now talking about this, let me just get back to my whiteboard a little bit here. Okay, grab my pen. So here, give me a second, let me get rid of this. Okay, so what really happens is in IPv6, right? So you've got your, so you've got your ISP, right? So this is your enterprise, right? And you have paired it with an ISP here, and the ISP generally gives you what? A /48 address, right? A /48 IPv6 address. What do you mean by /48 is, this is your 128 bit, right? This is 128. /48 means, you know, this is 48 bits, and then you also know that, you know, you're having /64. I mean, all your IP addresses, IPv6 is generally /64, right? So 48 ends here and 64 starts from here. So whatever you have here in between, which is how many? 16 bits, right? So you have 16 bits here, right? So those 16 bits, you can form so many subnets, right? Which is 2 power 16, which is what? Around 65536, I guess. Right? Such a huge number of subnets. So if you take one /48 address from the ISP like this, you can then break it into so many subnets, right? Which is 65536, I guess, 65536 subnets, and each subnet having /64, you know, mask, right? So that's how generally the division happens, or that's a very common way of doing it, right? Now, who gives IP addresses to the ISP? That is provided by the IANA, right? That's the authority, the body which actually gives. So when they give to the ISP, they give generally something like think of it as a /40 address, right? So they give them /40, so that this guy can then use probably, you know, 8 bits, so 2 power 8. So he can create how many 256, right? 256 /48 you know, networks out of it, right? So you can give this to 256 customers, right? So imagine this ISP is serving 256 customers, so you can give each /48 to different subnets, right? So this is how it generally works. So this DHCP prefix delegation basically comes in such a scenario, right? So imagine you're an ISP and you're the router sitting here, right? How do you, like for example, you know, today you're using ISP1, right? Tomorrow you might be using, you know, for your enterprise you might change. You might not like the service provided by ISP1 and you might switch, right? You might switch to say ISP2. So in that case, you know, how can you delegate the prefix and how can you configure the whole network without much changes, right? So that's basically addressed using this option, which is DHCPv6 prefix delegation. I've not seen it being used a lot, but you know, I thought probably let's put it here. It's in my notes, so I thought let's talk about it, right? And let's configure it, right? So to do this, what we'll do is in my topology, I'm going to use R4 as that ISP router, or think of it some kind of a core router, right? So let's go to R4 and let's see what we'll do on it. Right, so that's my R4. And if you do show CDP, I think the Ethernet 0/0 is the interface which is connecting R3. Okay, keep that in mind. So we'll configure. So on this one, we'll have to configure the pool now, right? So we'll say IPv6, right? So let's configure the same pool which we did earlier. We did it earlier on R3, but this time let's configure it on R4, right? So what we'll do is we'll say IPv6 DHCP pool 6 pool, right? The names are all locally significant, so you can use the same name here as well. and we'll say prefix, right? Prefix delegation. See, you have an option for that, prefix delegation, and pool, let's put a question mark, we can give a name. So I'm going to say local underscore 6 pool. I'll tell why are we using this, right? So, but then let's create a pool for now. I think you need to use a capital L here, right? So we're creating a local pool. Lifetime, you can change the lifetime or you can keep it default. I like changing it, so say 600 is the valid and 300 is the preferred lifetime of that prefix. And in addition to that, you can provide other information like what? Your DNS server, like we did earlier, 2001 DB8 :100 :100 :1, right? And you can also provide domain name if you want, bitsplace.com. All right, done. Now we'll define that pool which we defined earlier. So we'll say IPv6. We'll exact same name you need to replicate, right? We'll put in the pool. Sorry, I think we'll have to put IPv6 local pool and then the name of the pool. My bad. So it's local pool and the name of the pool. All right. So now this is the place where we need to define what I was talking here, right? Where is the diagram? So this is the place where we need to define the the /40, say INA, which has provided us, right? The /40 network. So let's put that. So the network will be 2001, say DB8 :100, okay, :100 and ::, right? Because it is /40. So /40. It need not be always /40. Maybe the INA has provided us even maybe /35 or whatnot, right? But I'm just using /40 an example here. Okay, what does /40 mean? It's basically 16 from here, 16 from here, which is 32, and we need what, 8 more, so which is the first 2, or so much, right? So much will /40 means that so much will remain constant always, the ones which I'm highlighting, right? But then you also need to mention what is the size of the networks you wish to give out. So I wish to give out for /48, right? /40 is what has been provided to me, but my pool which I'm creating it for /48 because I want to give every customer /48 networks. So you need to mention that. That's it. Now I can go to interface Ethernet 0/0, the interface which is connecting to R3, right? I can go into that and I can say IPv6 DHCP server, and let's put the name of the pool which you created earlier, right? 6 pool, this one. Okay, and we can also, I should have probably enabled debugging earlier, but it's fine. I'm gonna say IPv6 DHCP. Okay, so there you go. I enabled DHCP, the debugging as well. Okay, now so that's okay. There's one more command which we'll probably need, which is I just enabled the pool, but remember we always we can, to speed up the process, we can do that rapid commit, right? So we can, let's do that. IPv6 DHCP server 6 pool, that's the name of the server, and we'll say rapid commit instead. Okay, so that's good. Now let's come to R3. We'll come to R3, and as of now, let's see what has happened. Do show IPv6 interface brief. Okay, Ethernet, there you go. So we as of now, give me one sec. Yeah, so the interface which we need to be looking at is actually Ethernet 0/0 because that's the one connecting to R4. But I just noticed that I have forgotten to remove this, so let me do that. I shouldn't have that, so let me remove that. Do show run interface Ethernet 0/2. So I just, because the whole point is to get it via DHCP, right? So let me just get rid of that. So yeah, let's get into 0/2 and let me just remove that. I don't want that. All right, so let's come back. Let's come back to do show IPv6 interface brief. Okay, so what do we have? See here, Ethernet 0/0, that is the one connecting to R4, and you see we just have the link local. Okay, and Ethernet 0/2 also has just the link local, which means nothing has happened yet. So we need some command over here, don't we? Right? So we'll put that. So we'll go into which interface, Ethernet 0 0/0, the one which is connecting R4, sorry, mistake, 0/0, and what we'll do here is we'll say IPv6 DHCP client, right? And we need to client, and we need to put the prefix, right? So this is the router. This is the R3 is the router, which is like my edge router of my customer, right? And this is the one pairing with the R4, right? So we will, let's see what is the option you have, client, and you see prefix delegation. So we'll enable prefix delegation, and we need to provide some name here, right? So we'll say, we'll provide prefix underscore from, say, provider. Okay, so there you go, and then we can do rapid commit here as well. So once I did that, now the DHCP has started, and we can see that see the DNS server is being configured. But important point to notice here is this. See here, it is telling adding prefix 2001 DB8 : /48, right? This is the first /48 address. See here in R4 we configured that /40 subnet, right, or the /40 network, which was that here. So this is the pool which we configured, and this pool will give us how many? 256 /48 addresses, right? And what is the first one out of them? It is 100. The next one will be 101, and then will be 102, 103. So it goes till 256, right? So yeah, so basically, plus 256. So the first one is 100. So that's why, you can see my R3 has gotten that prefix. And you see, this is not adding this is not an address, this is the network. So R3, which is pairing with my R4, which is my service provider, it has gotten this whole network now. Okay, so you'll understand now. You might be questioning, okay, what's the whole point of this? Where is the actual DHCP working happening, right? Because if you see here, show IPv6 interface brief. So on this Ethernet 0/0, we actually just now got, this is the interface which is pairing with the ISP. So via that interface, we got that prefix. But now how do we use that prefix for our inside network, which is Ethernet 0/2 or Ethernet 0/3? How do we do it, right? So that's where okay, give me one sec. Okay, so how do we use this? Pretty simple. So we'll go to that interface where we want to use it. Like in our case, our internal interface is Ethernet 0/2, right? 2, right? Yeah, 2. It's 2. And that's the interface connecting 3 and 6. Right now on that interface, we don't have any IPv6 address. We just have link local, but we don't have anything else. So what we'll do is we'll say IPv6 address, and that prefix, we'll call that prefix, the prefix which we gave earlier. So the prefix is prefix from provider, I believe. We'll provide that prefix over there, and so now it will get the prefix from this one. Where is that? Yeah, this will be the prefix which it is going to use. Okay, but what is the host part? So we can mention the host part, right? So this is where we can mention the host part. So for this interface, I can provide the host part as so I can put double colon, so that represents the prefix part. Then I can say 36 colon, I can put anything, whatever host part I want. In my case, I want 36:003, right, and /64. There you go. So once I do that, you see earlier Ethernet 0/2 did not have the IP address, but now if I do show IPv6 interface brief, there you go, right? We have obtained the IP address, or we have obtained the IP address from DHCP. Cool. Similarly, I can do it for the other interface as well, right? I can go to 0/probably 1, the interface which is connecting, I don't know, maybe towards the up. So repeat the same thing, right? I can just take this whole thing, right? I can put it here and probably change this host from 36 to say 39, right? And if I do show IPv6 interface brief, you can see I have received 39 as well. Cool? Pretty simple, isn't it? Similarly, on my, the whole concept on my R6, I can go to my R6, and what do I have right now? Show IPv6 interface brief. What do I have? Do I have something? Ethernet 0/2, I don't have anything, right? So I don't have anything, and what I can do is I can go to that interface Ethernet 0/2, and I will enable your autoconfig, right? And let's see, wait. So if I do show IPv6 DHCP interface Ethernet 0/2, do you get? Okay, there is nothing. So I will have to, I mean, if I want R6 also to get the IP address via the method which I'm doing, I'll have to enable those flags. So let me do that. So let's go to that interface Ethernet 0/2, and what I'll do is I'll do IPv6 ND other config flag, right? And once I do that, if I come back to R6 here, there you go. Okay, see, now we are getting the information. There you go. So we are basically getting the interface. So if I do show IPv6 interface brief, yeah, there you go. I've received the IP, right? So we kind of got what we did here basically was we used R4 as some kind of a ISP which is giving out networks, and then we used R3 to kind of capture those prefixes, right? To kind of collect those prefixes and then use those prefixes, right? To assign IP addresses, within my network, right? So what I can do along with this is I can now use, I can also configure what we call as the DHCP relay, right? It's a pretty common configuration, right? So what I can do is I can, on this interface, right, I can also configure the DHCP relay, which means I'll have to just do IPv6 DHCP relay destination. So this is the common configuration which you do, right? So you grab the prefixes from the ISP which is providing to you, which is R4 in this case, and then you set up a relay so that you can what is the IP address of the R4, which is FE80:4, and the interface will be Ethernet, I believe, 0/0, right? Outgoing interface, right? So that's how you configure the relay. And once you configure the relay, you will have to probably do a shut and no shut here. So let's do a shut and no shut, right? So once you do that, once it comes back up, we should see that it should get actually it should get all the information directly from the DHCP server, right? So there you go. I think it has obtained. So if I do show, there you go, right? See, it has obtained the domain name, it has obtained the DNS server and all the information from R4 directly. So right now we kind of used R3 as a relay agent, and we forwarded all the DHCP request to the R4, and we got information from that, right? So that's pretty cool, right? Now the benefits of this, what is the benefit of this? Now if I'm moving away from one ISP to other ISP, right, I don't have to do a lot of changes. I just need to, on the new ISP, right? Let's actually try that. What we'll do is, let's do that. Let me show you. So what I'll do is show run section IPv6. Okay, so let's grab that. So what I'll do is first is let's remove this pool which we have here. So let's remove the pool once, right? And let's remove that local pool as well, which is over here. So what I'm trying to do is I'm trying to simulate and tell you that I'm moving away from one ISP to other ISP. Okay, so let's put this pool again, but we'll change this time, right? So let's put the same pool, but instead of 100, I'm going to change this to what, 99 maybe, right? Let's change it to 99, right? So there you go, I've changed that. And let's put that pool back again. So this pool, right? Let's put that pool back again. Okay. So now just by doing these two config changes, which means I'm just showing you that I'm moving away from R4 to some, to a new ISP. What we'll see here is, let's look at this. On R3, do show IPv6 interface brief. right? Okay, so it's still not picked up. Maybe I might have to bounce it here once, right? Otherwise it'll happen until the IP address is timeouts. Okay, I think it probably happened now. Let me see. There you go, right? See, just by moving it from one ISP to other ISP, we have obtained the IP addresses from the new ISP, right? And my whole, not just these guys, right? Even my R6 will basically end up getting an IP address from there, right? There you go, right? So you see the advantage of this. So it's something which you probably not use every day, but yeah, prefix delegation can be used in this way where, if you want to move from one ISP to other, all the internal IPv6 addresses can be enumerated automatically without doing any extra work. Okay. So thanks a lot for watching, guys. So that was probably the video went a little longer, but yeah, I just wanted to cover all the options here: static, SLAAC, stateless DHCP, then a full-blown DHCP, and then we had the DHCP prefix delegation. Okay. Thanks a lot for watching, and have a good day.